exploring what we call angle pairs. There are lots of sets of angles when lines intersect, when angles intersect, when we've got these different things. You're going to create things that are called angle pairs. This relationship between these angle pairs is going to be very important. You're going to use it to set up problems. You're going to have to know whether you're going to use it to add things together to equal 180 or to set them equal to each other. Those are going to be your only two options, guys. You got to know when to use one and when to use the other. So here we go. First things first, the type of angle pairs. The first one is going to be adjacent angles. Guys, what does it mean to be adjacent to something? Next to it. Very good. Exactly right. Adjacent angles. So it's two angles that share a common side. Now, pausing there before we do anything else. Common side, guys, a common side is a ray. I need to make sure you understand that the side of an angle is a ray. So it is two angles that share a common side, which is a ray, and a common vertex. But, this is the key. They can't overlap. They can't overlap. Alright, that's an A. They can't overlap. The whole idea, guys, is they have to be beside each other, not over top of each other. Alright? If they're over top of each other, they can still share a common side, common vertex, but that does not make them adjacent. If they're going to be adjacent, they got to be next to each other. You can see down here, these two share a common vertex right here and a common side right here. That means that angle 1 and angle 2 would be adjacent to each other. And you have to be able to name angle 1 and angle 2 would be the adjacent angles there. They're going to ask that question on the test. On the next one, we have two angles that are adjacent. The common vertex is B. The common side would be the ray BC. And then the adjacent angles are going to be the ones that are here. They're not necessarily congruent. They're just adjacent to each other. So I'm not using the curved one that makes it so they look the same. Okay, those would be angle. Guys, how would you name the one that's on the top? ABC. How would you name the one that's on the bottom? C, B, D. There you go. Bless you. You can also name them backwards. The only difference is you got to make sure that the B is in the middle. What is the B called again? Vertex. That vertex got to be in the middle. Anybody have any questions about adjacent angles? Adjacent angles share common side, common vertex, never overlap. They just got to be next to each other, guys. That's what makes them adjacent. When things are next to each other, they're adjacent to each other. Your neighbor is adjacent to you. Okay, here we go. Anybody still writing? Wonderful. Let's keep going. The next time, these are things that you've seen before, guys. They've talked about this. This is in the skills that go in algebra and the 8th grade skills, 7th grade skills. They have supposedly taught you this before. I'm going to show you it like you've never seen it before. Okay, guys, the easiest way to remember it is complementary and supplementary angles go in alphabetical order. Complementary angles is going to be two angles that add up to, which one, guys? 90. C comes first in the alphabet, so it's the smaller of the two. That's the easiest way to remember it. Okay, they go in alphabetical order. Supplementary angles are going to be two angles that add up to what? 180. I'm going to let you get that down, then we'll talk about them so you can look at them. So, complementary angles are going to make a right angle when they put together. So when they're next to each other, when they're adjacent to each other, they're going to form this little right angle right here. And you're going to see that symbol in there. They could also put the measures in there, but it's a right angle, so they put that symbol. That's what the right angle symbol is. That means that angle 1 and angle 2 would be complementary. You would have to be able to tell me that. Angle 1 and angle 2 are complementary to each other. Now, looking at angle A and angle B, are they complementary also? Yes or no? Do they add up to 90? Put your back in the front, take your folder out. If you got your homework, bring it up to me. No, so before you go, we've got test day. You don't pick up your desk. We've already started the whole process. Grab your folder, pencil. You can grab the papers and the calculator. Okay. The answer is yes. They don't have to be adjacent in order to do that. So angle A and angle B would absolutely be complementary to each other. If they add up to 90, doesn't say anything about where they are located at. They don't have to be next to each other. I put a note about it at the bottom. They do not have to be adjacent or touching in order to be complementary or supplementary. Now, if they are supplementary, how do I know that these two are supplementary? Because every line adds up to what? 180. Every line is going to add up to 180 degrees. Therefore, angle 3 and angle 4 would be supplementary to each other. Your folder, and then bring me your homework. So, from here, these two add up to 180 again. So again, angle R and angle W would also be supplementary. Grab those two sheets in the calculator while I look this over real quick. Here you go, sir. When you get done getting those, come grab this. I'll put this on here so you don't even have to wait. Here you go, sir. Because we're going to check this in a minute. I'm going to go ahead and put it on there for you. There you go. Okay. Thank you. Did you put phone and everything else up front? Is phone up front? Because if you have a phone, it's going to be a 0 on your test. Okay, I just want to make sure. Okay, guys, here we go. So for the next one, this is going to get into two that you're going to see quite a bit, guys. They're going to expect you to know how to use these. These are literally all year long. I cannot stress this enough. You'll see complementary and supplementary. We use that more in problems than we do itself, the actual naming them or anything like that. You use the idea that they add up to 90 or add up to 180, but these you're going to see all the time. Vertical angles. Okay, to define vertical angles, they have to be across from each other. Look right here. 2 and 4 would be vertical angles. 3 and 1 would be vertical angles. Those are vertical angles. Do you see it's 2 V's? See how they point at each other? Vertical, 2 V's. Okay, it's going to be 2 vertical angles. Vertical angles are going to be across from each other. So it's 2 angles formed by intersecting lines formed by intersecting lines that are across from each other. Two angles formed by intersecting lines that are across from each other. Now, why are these angles so important? Because they're always going to be congruent to each other. Guys, if they're congruent, what does that tell you about them? They're the same. So if you know that this one is 50, then you would know that this one is also 50. It's important to know that because you're going to use that a lot going forward in solving problems and doing things. You're going to notice set them equal to each other if you have a problem where you have vertical angles, because they would be across from each other and you could set them equal to each other. So vertical angles here would be angles 1 and 3, and then angles 2 and 4. So what are the vertical angles in the next picture with the 5, 6, and 7? It's a trick question, guys. Darn. It is a trick question. What if I extend this line out this way and this line out this way? Do you see the 5 would actually be across from this angle, the 7 would actually be across from this angle, and the 6 would be across from that angle? Are any of the ones that are numbered directly across from anything? Do they look like it at first? Yes, but are they? No, so you have to be careful. There are none here. There are no vertical angles in that picture. Even though it looks like it when you first draw it, when you first look at it, when you actually look at the original picture, none of the, that thing's tiny. None of the numbered angles when you look at that picture are vertical to each other. At first you think they are, but they're not. Be careful. Okay, the next one, guys, should make sense, but you got to get out of it what you need to get out of it. So let's first talk about what it is, then we'll talk about what you need to know, because like this one, you need to know they're equal. Okay, they're congruent. You're going to set the amounts equal because they're vertical to each other. On this one, a linear pair, guys, what does linear mean? Line and pair, two of them. So it's going to be two angles that are adjacent. That's key. They have to be next to each other. Two angles that are adjacent. That means they have to be right next to each other, sharing that common side, common vertex. Two angles that are adjacent. Okay. And what do you think it's going to make? A line. There you go, a line. That form a line. And someone else said something else that does apply, but I can't tell where it came from. So, guys, if it forms a line, what are you going to know about it? It's going to be 180. What is that called when two things add up to 180? We already have that definition in this set of notes. What adds up to 180? Supplementary angles. Very nice. They're supplementary to each other. I thought I heard that earlier. I don't know where it came from, but I thought I heard that. So these two angles are going to be supplementary to each other. That means you know it's always going to add up to 180. So if you have two angles and you see a straight line, what are you going to do with the answers? You're going to add them together and set it equal to 180. If you have vertical angles, what are you going to do with them? What would you do with these two angles? If I had this one as x and this one as 5. I know it's not 5, but what would I do? Set them equal to each other. Vertical angles I said equal. Linear pairs I would add them up to 180. That's the whole thing. Is that the door? Okay. That's the whole thing that you are trying to learn today. That's the key to being able to set up the actual problems that we're going to do, is knowing that part of it. Yes, you got to know what they're called, but you also need to know the other part. Okay, stop right here. Back down. Take your folder out. Put your phone in your bag, all that good stuff. That's thing. Okay, guys. So, guys, right here. Oh, wait, we didn't name these. I'm sorry. Let's name the linear pair. So the first angle is going to be angle PQR. If the first one is PQR, y'all tell me the second one. RQS. Perfect. RQS. Awesome. Now, this one, it's a trick question again, guys. Are there any what is it called? Are there any linear pairs here? No, because if this one extended, there's your linear pair. If this one extended, there's your linear pair. If this one extended, there's your linear pair. Wait, so hold on a second. So, do you have your homework? Do you have your homework?
I think I was absent.
Were you out yesterday? Well, you either were or you weren't. Let's look. Yes, you were. So you're good. So you need to grab, oh, sorry. No, you're good. You're fine. I'm sorry it fell. So grab those two sheets and a calculator just so you don't have to get back up again. You're good. Take your time. You're fine, sweetie. So there are no or none of the linear pairs right here. Okay, none of those. Thank you. Okay, guys. So moving on from this. Angle bisector, I think, is our last new topic. So angle bisector, guys, we already talked about segment bisector. Angle bisector is going to be the same thing. In an angle bisector, though, it is always going to be a certain shape. What shape is this thing I just traced over in blue? What is this thing? Not a line, a ray. So it is going to be a ray that cuts an angle into two, I don't know if I said congruent parts, I think I said congruent angles. Congruent angles. I try really hard to make sure y'all's definitions are exactly the same. A ray that cuts an angle into two congruent angles. So in this case, if I asked you for the bisector and you had to name it, What would the bisector actually be called? BC what? What do you say when you say BC? Because you can't just say BC. There we go, ray BC. And to show that, you got to put the ray symbol pointing to the right. It has to point to the right, guys. That's the only direction rays go. They have nothing on one end and an arrow on the right-hand end. Okay? If I ask you for the two angles that are now congruent, what two angles are congruent? Angle ABC would be congruent to angle CBD. There we go. Okay, guys. What would you do with those two angles if you had them? Because they are congruent, what would you do with their amounts? Set them what? Set them equal to each other. When you have angle bisectors, you're going to be setting things equal to each other. Okay, yep.
Is this the formula place?
No, God, no. Y'all, she asked a great question. Am I going to put this on the quiz today? No. I'm not going to put something I teach today on the quiz. No. It'll be on the test. Yeah. We haven't had a chance to ask questions about it, do problem. No, I'm not going to do that to you. I know some teachers do. I don't. Okay, guys, there's only two choices. What are the only two choices? They either are equal or they add up to 180. Now you could, there's not any on this, but you could have one on the homework where they added up to what else? What other thing did we get when they added up to 90? If you had complementary angles, they could add up to 90. None of these do. These are only going to be equal or added up and set equal to 180. You got to pick which one it's going to be. For this first one, this is a linear pair. These two are adjacent to each other. That would make them supplementary, which means they add up to 180. So we would set 2x plus 24 plus 4x plus 36 equal to 180. That's the geometry. Everything else is algebra. Knowing to set them equal to 180 is what you need to learn from this. Okay? So 2x and 4x go together to give you 6x. 24 and 36 go together to give you 60 equals 180. We minus 60 minus 60. We got 6x equals 120. Divide by 6, and x equals 20. Now, does it ask us to plug it back in? No, it just asks us for x, so we don't have to go any further on these questions. It could, but it doesn't. It could ask us for one of the angles. If it does, we'd have to plug it back in. Okay, on the next one, our only two choices are they're equal or they add up to 180. What would it be for this? They're equal. Because this is a bisector and these two are marked congruent, you would just set 7y minus 1 equal to 55. These are the only two choices. Equal or 180. You could do 90 if they gave you one. There's just not one on this set. So here we go. Plus 1 makes it 7y equals 56. Divide by 7. I always switch up 9 times 6 and 8 times 7. I always switch those two up. This one is going to be 8. Okay. So based on that, do not solve them, but set up the problems for these. Oh, pause, stop, everybody look. Guys, we went through this. For some reason, the examples are on like the original set of notes, but for some reason when it saved it as a PDF, it like blanked them out. Please label it right now. Example 1, example 2, you'll be expected to have this for the folder check, so I need to make sure that you've got these. Example 4. E1, 2, 3, and 4 in that order, going across. 1, 2, 3, 4. Do that real quick. Yep. Because every straight line adds up to 180. And since together they form a straight line, that would add up to 180. Good. Thank you for asking the question. Linear pairs, things that make lines, are going to be supplementary, which means they add up to 180. Good. So, set up 3 and 4. Just set them up. Set them up on your paper. See if you can get them set up. I don't need you to solve them yet. Just set them up real quick. I want to see if you can set them up correctly. look up here, see if you set them up right. We okay on the setup? Does anybody have a question why example 3 is set equal or why example 4 is set equal to 180? Anything? Yes.
Is it because we know number 4 is 180 but we don't know what number 3 is?
Say it one more time. I'm sorry.
Is it because we know example 4 is 180 but we don't know what example 3 is?
That's why we know example 4 because it's a straight line, so we know it's 180. How do we know in example 3 to set them equal? Because it's got congruency marks, which means this is a bisector, which means they have to be equal to each other. That's how you know from those little marks. Those are those congruency marks saying those angles are the same measure. Good. Thank you for asking the question. How do you know? That's important in geometry. How do you know? Okay, here we go. So you're going to minus 3x minus 3x. That's going to make it 32 equals 6x minus 4. Add 4, add 4. 36 equals 6x, which means when you divide both sides by 6, 6 equals x. A lot of 6's in that one. Okay. For the next one, you got to be careful on this one because people are going to forget to do this. You got to combine like terms. Please be careful about that. That's going to make it 9x plus 90 or 90 plus 9x. It makes absolutely no difference which one you put in front. I'm just an algebra teacher too, so I tend to put my variables in front because that's what you got to do in algebra. Then you got a minus 90, which makes it 9x equals 90. And then divide by 9, and x equals 10. Okay, guys, do y'all get the concept that what you need to know is the vocab? You do need to know the vocab. But the whole idea is, are you setting them equal? Are you adding them up to 90? Or are you adding them up to 180? That's what you need to know. That and the vocab. Okay, guys, put that in your folders. The next thing that we are going to do is we are going to flip to the assignment that I already checked.